Hello, and welcome to Learn Masters on AI. My guest is Morten Goodwin, and we are in lecture 3. And this lecture is going to be about where do you go now? How do you get started using some AI in practice? The tools and the tactics of this trade. So, Morten, welcome back. And
thank you.
what would your startup advice be? And I don't mean entrepreneurs, but I mean anybody thinking that maybe I should use AI.
Well, there are many ways to start. I think first is to think of what is the problem you're trying to solve first. I think you should have this problem-solving mind before pouring on AI on top of it. So often most people are an expert on some domain, meaning that they have their professional experience in, I don't know, boating or health or finance, etc. And that is often a good way to start. So understand what you're trying to solve, just outside of the AI world. What am I trying to predict? What am I trying to classify? What am I trying to categorize? And understand that in some level of detail first. And then you can think, so with this example, I can really go about using AI. And when you do that, when you understand that, then I would say it is not necessarily so that you have to be full-scale nerd, understanding everything, but at least trying to play with some examples. And there's a lot of resources out there that you can use to kind of learn the tricks and trade and basic examples. There's what I personally often advise is to be in some of those online competitions, meaning then you get a lot of data that is already chewed quite well, so cleaned up nicely. There's many of those competitions. In the last podcast, we talked about the DARPA challenge competition, but there's, for example, Kaggle has a lot of these type of competitions on anything. And even NORA, this Norwegian AI Society, has a dataset competition. There's one out now, but we have many that comes many times, and particularly now it's some sort of medical diagnosis. But why is it's good to use those competitions as a starting point? The reason is that you can learn a lot from a very, very concrete example. You avoid the messiness of real world data, and it is very, very concrete on exactly what is solving. So you kind of abstract away most of what is part of real world, and then you become expert on the AI. Yes.
Just so I understand you, it's a sort of a sandbox game where they clean the data, prepare them within a particular problem, and then they give you a problem and they say, whoever solves this problem with the highest precision, the most interesting solution algorithm wins.
Yes, that's roughly it. Yes, exactly. And it's not necessarily only the highest precision or highest accuracy, but it sometimes is highest accuracy and an explainability level to it, for example, or so means that you cannot be just enter a black box system from a company that doesn't tell you anything, but has to kind of explain at the same time. So, for example, this NORA competition has explainability as a level. So that means that you scored by 2 points. One is how accurate is it to diagnose these malicious tumors, which is the case, and then how good are you at explaining why this is a malicious tumor or not. So 2 important levels. And often it has more than just the accuracy of it, depending on the problem area. Because sometimes you just want a high accurate system. Sometimes you need a bit more there. And competitions are very, very good at that. And then, as an added bonus, often because when you do these competitions, you become an expert on your own solution. When the competition is finished, often in most competitions, at least the NORA one, it's publicly placed openly, all the submissions, and then you can see what these other submissions did that you did not. So maybe you came in 10th, there's 9 people better than you, and then you can learn a lot from those examples already with the expert knowledge of the data set that you're there. So it's a learning experience, but it's very, very controlled one.
Well, Morten, can I just stop you for a second?
Sure.
Because before people have the courage to start playing with competitions, and I don't know how many people, with full-time jobs and too much other stuff going on, have the time. You mentioned courses, and so I just want to make a comment. First of all, that we are not trying to compete with university courses. This is an inspiration conversation to open up a subject and make people want to take one of these courses. And then my question is, which courses are available digitally for somebody who can listen to them in their, evening time? Or, I know that you have courses for grown-ups, post-education, lifelong education at University of Agder, but are they physical and are they full-time is my question.
Yeah, so my courses at the university is for people who have already some computer science background but want to learn AI. It's not full-time, it's part-time, and we have one physical session and then the rest is digital. So that we meet and greet, etc. So for that particular need, it's very good, I think. But if you want to be fully digital, there is a lot. You just have to Google, but Coursera has one great series on it at different technical level. I think MIT it has a great series. They're quite heavy, some of them, if you're interested in that sort of stuff. A person called Andrew Nee is key to that one. And those are more like evening lectures that are free, and you watch video lectures, and then you sign in or submit some sort of code or some sort of thought experiment, and then you get feedback from it, and you get like a small degree or some confirmation that you've completed it. And even my students do that because they get more input that they cannot really get from there. So, but it's at a different level. And of course, this it's rather basic, but it's called Elements of AI, which is was international. I think maybe it started in Finland, but at least now it is available in Norway. I think Norway. Also, yes, and that is a very good starting point, I think. But I think you have to think, so at what level do I want to be? Do I want to be a developer? Then you need to go a bit heavy into stuff. Am I a user? Then maybe Elements of AI is enough, or some YouTube videos or Coursera course. Or if I want to be a entrepreneur, innovate in some part, maybe it's good to get my hands a bit dirty, do some competition, Kaggle competition or Nora competition or something like that, I think.
Yeah, I agree. So my problem is that, when people ask and you start looking for courses for them on the net, much of it is, my favorite is the Andrew Ng course that you already mentioned from MIT, but it's heavy, It takes time, and it takes quite a lot of pre-skills. And Elements of AI is great, but it's also a bit on the technical side for too many people. So the question is, whether we should maybe start advising people also to look for good TED Talks on a particular topic. They're usually fun, they are short, they are very colorful. And if we could think together with Nora, and this is basically an invitation to dance, on some sort of an AI play school for grown-ups, so finding a way into this topic without having to get your hands dirty with any programming, because I think most of our audience will be not implementers of the solution. They will be buyers of the solution. So we have to help them become good at understanding, what's the problem, what data do I need, what are my hypotheses, and then who do I go to get this implemented?
I like your idea, and of course we want to dance. But so that's happy, and we have partly that already at Nora, as you said. So we have these weekly webinars, and the key there is every second week there's an academic professor, or associate professor, or a lecturer that gives some sort of information. And the alternate weeks, the startup environment has a key role, meaning that you want to do some business, you want to innovate in some sort. May not be heavy research, maybe it's research inspired, and it's more about the tools and the trades mostly. I would recommend people to follow those that at least they find interesting. There are probably a lot at LØRN as well that you can do the same, but it is about understanding. So if I do voice recognition, this is kind of the libraries that are available. If I do image recognition, these are the libraries that are available. If I want to do the prediction of medicine part, this is the tools that are available. And there is a lot, and it's a jungle to go after, I think, mostly.
So I want us to talk a little bit about libraries as well, because I think many people think, well, God, if I'm going to make, an AI to do something interesting on medical images or on traffic images, or, I don't have the millions of dollars to do that, but there are these amazing libraries that have been made. So if we just know about the 4 or 5 most famous ones internationally, and then maybe you could tell us a little bit about developments in Norway as well.
Sure, absolutely. So there are many.
I just want to give people an image to keep in mind. So, and please correct me if I'm wrong, but Tensorflow by Google is a language AI library. Well, is it both written and spoken, or just spoken?
No, it's a computer library, so it's written. Yes. So it's like a software library.
I mean, is it for spoken language only, or is it for?
It's for anything. So you can. So the key with TensorFlow from Google is that you can develop these neural networks from scratch if you want, but there is also a lot of pre-trained examples. So meaning language recognition, for example, and then image recognition as another example. So because when you train an AI system, it's very seldom that you start from scratch, because that's very, very costly. You often start from some place, and TensorFlow, as a key example, gives you that starting point if you want to do image recognition or if you want to do voice recognition.
So again, please help me navigate my failing memory now. But I remember about 2 years ago, I think, when Google turned on deep learning in TensorFlow, I guess, and they were using this to translate. So language translate, Google Translator has been working for many years, but it was really quite easy to see that this is Google translated rather than, human translated. And then once they turned on, I think, deep learning, it is using libraries from TensorFlow, I think. People got shocked by the sudden, over one day improvement of quality, where it suddenly started translating almost as good as a human.
Yes, it was. So they turned on deep learning, and they absolutely use TensorFlow as a library, and more specifically a part of it which is called BERT, and that is like a language-based system that is very, very powerful from Google, and we often measure translation in something called Blau score, and it reached a Blau score near human perfection, but not at human perfection, but near. So that means that for the cases where you have a lot of examples in translation, it became very, very good, almost like human. But in the cases where you have very few examples, it kind of falls short, and it still does. And that BERT TensorFlow-based system is in Google Translate, and it is in a Google search. It's so before it was kind of word lookup like that, but now it's a deep learning-based system that means that if you search for something, it finds the synonyms, it finds the kind of information that is related to your search, not only word lookup, which was the old-fashioned way. And that means that most people have already used those systems, but maybe not as libraries, but as tools. So the competition to TensorFlow is called PyTorch. So that's from Facebook. So they're kind of competing with each other. So TensorFlow develops some sort of mechanism, pre-trains a lot of algorithms, and then PyTorch does the same. And they kind of, like Coca-Cola and Pepsi, like they're kind of continuously innovating. And without Pepsi, Coca-Cola would be worse, and vice versa. And it's the same here. So they kind of play with each other. Yes.
So again, for people who are not, masters of computer science, how do they get any value out of these libraries? Should they know what's possible and available, and then talk to somebody who will be programming for them, or do you expect basically people to learn Python because it's really, you and I can say, well, it's just another language.
Yeah.
But I think for somebody who has never programmed, it's unsurmountable.
I think if you've never programmed, I think going into TensorFlow or PyTorch, it's too long a stretch. But you of course can get there because you can learn, but still it's challenging. I think for those libraries, it is more useful to understand what has been available or is available directly, and then you can ask someone to help you do the software programming, or you can and there's some visual user systems that you can test as well. I think one is called Orange, one is called Nime, and these are just it's the same type of thing, but you draw boxes and you play boxes, meaning that you kind of like PowerPoint, you draw in an image of this, an image of that, and an image of that, and then you can say, I draw in my data, I put in my data, I put in my algorithm, I put in what I want to do, and then it kind of does it for you. And at least for learning what is happening with, for example, Nime, spelled with an extra K at the beginning, Nime, and then that is very useful to understanding. When you put it into production, you probably want some sort of development system in there, but then there's a lot of possibilities, people to collaborate with. And Nora, as we mentioned there's a lot of university examples also. CARE, which I come from, I'm particularly fond of because that's my home world. But we also have several AI hubs that kind of help you in this type of way. So it means that if you're a company that wants to innovate in AI, I suggest that you look for some of those places. So NTNU has this open AI area, and then much of the rest of the academic world has Nora, including Nora Startup, and then there are several others also. But these are the ways to connect researchers, programmers of AI with entrepreneurs and innovators. Because researchers, we often would just want a problem to solve, and we have the competency. So it's kind of...
I think it's really good how these research environments are now connecting to the real world industrial needs, and also there is a group of students, I think, at your own university that can be used as chaos navigators, chaos pilots in the world of AI. So you can go to them and they can help you dissect your problem and come up with the first outline of a solution, which you then have to go to a programming environment. And I think most consulting companies by now know how to get an AI part of your system up.
Absolutely. But I think you're pointing to something very important, because first part is always to understand, can I use AI at all? Do I enough data? Is it discriminatory enough? Can I really separate between this and this classification part? And that's requires some knowledge, but students can absolutely do that. And I think when you say that connection to real world problems, yes, but that is something that has happened very recently. Partly because the Norwegian Research Council funds a lot of projects on that, and Innovation Norway funds a lot of projects on that, but also because we see that AI is far removed from these toy examples as it was 10 years ago. Now we're really solving real world problems because they're so much more interesting and they can really do it. And that happens all over the world. And it's, as we talked about in other podcasts, it's like a Cambrian explosion. When people understand that we can solve these complex things with AI, everybody does. And if you have an idea, go ahead, because soon somebody else does it for you.
Very good. I think we're going to stop our third conversation, our third lecture here, and then in a couple of minutes, we will continue with a workshop. And I very much look forward to the workshop, because it will help me understand how to start using AI on my own example, which is LØRN.
Great.